In section 2 of chapter 2, we're going to take a look now at the background for problem solving, writing and simplifying algebra expressions, and then solving equations. And we'll do some background to start off, and again, take some notes on this. We want to look at what are called consecutive integers, such as 5, 6, 7. These are consecutive integers. And we'd like to write these integers using algebra. So let's say we didn't know what 5 was. We could call that x. Now, in terms of x, if x is 5, how would I write 6? Well, x plus 1. And how would I write 7? X plus 2. Now, if I were going to add all these up, this is 5, this is 6, this is 7. The sum of these three numbers would be how many x's? 3x, and 1 and 2 is 3. So the sum of three consecutive integers in algebra is 3x plus 3. And that's what they're showing you. Now, how about if we had even integers? Well, this would be 6, this would be 8, and this would be 10. Now we're defining our first integer as x. That's a 6. How would we write the 8? X plus 2. And the 10? X plus 4. Now the sum of these three consecutive integers, even integers, in algebra would be still, we have 3x, but now 2 and 4 are 6. So these were consecutive integers. These are consecutive even. Now let's do odd. 7, 9, 11. Now if our first integer, which is odd, and we're defining that as x, how many more do I need to get to the next odd integer? If our first integer is odd, we're defining that as x. And you might say, well, you just add 2 to it. And to get 11? Now, most students notice that this is sort of strange because this row and this row are exactly the same. And if you were to add these up, you would get 3x plus 6. But the key is, how do you define your first integer? If it's even, adding 2 gives you the next even. If it's odd, adding 2 gives you your next odd. So there is some mystery there. How could that be? Well, again, defining the first integer as odd, adding 2 gives you your next odd. Students sometimes think they have to say, well, odd is x plus 1. No, you're defining that first as odd. Then x plus 1 would be even. Ah. Okay, and that takes care of what they're showing you right here. Now in example 1, they're asking for the sum of three consecutive integers if x is the first integer. Well, x is the first, x plus 1 is the second, and x plus 2 is the third. And the sum, we said, was 3x plus 3. And they show it here in some detail. Now, another good technique when you are using words to describe something is to make a picture. Here they're saying the perimeter of a triangle with sides x, 5x, and 6x minus 3, and they've just indicated that here. How would you do that? Well, you're going to add all these sides together. So x plus 5x plus 6x minus 3. Add all your x's. This would be 12x minus 3. They're just asking you to add the three sides of a triangle. This would be your perimeter. So we started off easy. Let's go on to example 2. Now we'll pause as you read it. So in reading this, you should get that there are 3 cities discussed in terms of their population, with Tokyo being the first. Mexico is the 5th most populous, and New York is slightly less than Mexico City. So, and these are all in millions. So what we don't know after reading this is, what is the population of New York? Well, we're going to say New York is X. And that's how they set it up. Now, Mexico, we said, is a little bit larger than New York. So there's New York, and that little bit larger. So this would be the representation of the population of Mexico. And then when they discuss Tokyo, they say it's twice what New York is, minus 2.19 million. So, in a sense, this is the algebraic representation of the 3 cities. So how would you combine these like terms? Well, again, you string them out. There's no negative in front of the parentheses, so we can just remove the parentheses here. And then we collect like terms. So we have 1x, 2x, 2 more x's give us 4x. And then we add this to this, which is sort of a subtraction here. And we get then, for an end, algebraic representation of the population of these 3 cities as 4x minus 2.16. So what we've done so far is convert words into algebraic expressions. Now what we want to do is have these algebraic expressions in a form of an equation and then solve it. And there is a general strategy for this. The first one, we did some of this already, is to read, reread, read again, to become comfortable with what the problem is asking us to do. So read, reread. Now, what might help in some cases is to do a drawing, as we did for the triangle. We'll do that for rectangles. We'll do that for boards, a length of a board. We're going to try to visualize what's in the word problem to put it into an algebra problem. and we're thinking of a possible solution, getting an idea what we should have at the end. Then we choose a variable to represent the unknown. Now, if we're dealing with a formula like rate times distance, or I should say rate times time equals distance, then we might use the letter if the unknown is the r, or if the unknown is t, time, or if the unknown is distance. We might use these letters. And then in many occasions we'll use the letter n. Or in other cases we might use the letter n for an unknown number. Now we would never use the symbol O as one of the letters because it looks too much like a 0. And often an S in this form might be confused for a 5. So we're careful of the letters we choose so we don't end up with confusion. Then we carefully translate the problem into an equation. Then we solve the equation, and then if we get something, like we say distance is 40, but they didn't want distance, they wanted time, we'd have to do some fiddling to get time, again using this formula. So we give what is called a statement, the answer statement, where we check what are they asking and are we answering what they are asking. Okay, we'll do some. So in example 3, they're saying find 3 numbers such that the second number is 3 more than twice the first number, and the third number is 4 times the first number, and the sum of the 3 numbers is 164. Now you could read it here, but what I'm going to do is just using this, think of a technique how you might do it. Well, as we read this, we don't know anything about the first number. So we're going to say let, and you don't have to write this, but this is how I was taught years ago. Let x equal the first number. So we don't know what that first number is. Now as we look at the second number, it's saying it's 3 more than twice the first number. So the second number is going to be twice the first number. So there's our first number, so twice the first number, and is 3 more than that. So that's what the second number is. Now the third number is 4 times the first number. And we had pieces of this in chapter 1. So here's the first number, algebraically, the second number, the third number. And we're saying that these x plus 2x plus 3 plus 4x equals a total now of 164. Now there's our equation. So how do we solve it? And I've run out of room, so I'll put it up here. There's 1x, 3x, 7x. So we have 7x then, as we group like terms, plus 3 equals 164. Now, we have carefully read the problem. We defined each of the numbers. We didn't know anything about the first, so we let that be x. And then these others were described in terms of the first number. And now we have our equation. We're going to transpose this. This is 161. Now we're going to divide both sides by 7. And we get x equals, then I get my trusty calculator, 23. So the first number is 23. Now 2 times 23 is 46. 46 plus 3 is 49. And 4 times 23 is 92. Now theoretically, if we add up all these numbers, it should add up to 164, and it does. And that is the solution then of example 3. And your textbook will take you through this as well. And we'll just scroll. And then we get our solution. So if the first number is 23, we then found our other numbers. And remember, they've asked for what are all 3 numbers. So you have to include all of them in your answer. Now, some background that they're going to give us here is the word percent. That means per hundred, and has the symbol, percent symbol. Now, 23% is 23 per 100, or 23 over 100. And that would be written, and the short rule, when you have 23%, I'll get it here in just a moment. 23%, and you want to change that to a decimal. Now right now the decimal point is here. You take away the percent sign, and we think of this as a 0 and a 0, and we move our decimal place over and then add a 0. So 41, if we were to change it to a percent, would move it over 2 places and add the percent sign. So if we want to find the percent of a number, and we're going to change this to an equation, we would change the 16% to 0.16. The word of implies multiplication. So 16% of 25 is what number? And you just multiply that, and you get n equals 4. Now, here's just a little review of some percents. Let's just raise it up. This is important background. So 50% is 1/2 of something, or half of a number. And 50% of 60, half of 60 is 30. 25% is 1/4, or 25 over 100. Or it's a quarter of a number. And 25% of 60 is 15. 10% or 10 tenths, 1/10 of something, 0.1, or 1/10, another way of reading that. 10% of this is 6.0, or just plain 6. 1% is 1 over 100, or 1/100ths of a number, and we move the decimal place over 2 to make it a percent. Now, 1% of 60, we're going to move the decimal to the left 2 places, and that would be 0.60, or just 0.6. Now, 100% of a number of 1 is just the whole number, and 100% of 60 is 60. Now, 200% doubles what you had, twice or double a number. 200% of 60 is 120. And let's look at this concept check here. Suppose you are finding 112% of a number. Which of the following is the correct description of the results? The results is less than x. Well, 112% of a number is more, so it would be C, and it wouldn't be equal. Going on now to example 4, finding the original price of a computer. So you want to pause, we will pause, and then read this carefully. So after reading it carefully, there's an 8% decrease from the original price of a computer. If it costs this after the decrease, what was the original price of the computer? So, let's set up a little equation here. Now we're going to say that X was the original price. But now that original price has become 2162. Now, even though it looks like an equation, it's not, because this is the original price and this is the new price. Well, if you have an 8% decrease, this new price represent what percent of the original price? If it's an 8% decrease, what percent does this represent? So you take away 8% from 100 and you get 92%. So that's what this represents. So if we take 92% of the original price, this is what you get. Now it's an equation. And to solve it, you're going to divide both sides by 0.92. And we get X, which is the original price, equals $2,350. Okay? Now they're doing it a slightly different way here, which you can read. That would be fine. And again, I'm featuring this way. So 8% decrease of the original price gave you this. So this amount represents 92% of the original price. And this is your answer. All right, in example 5, they're going to ask you the lengths of a triangle's side. So let's read the problem. Well, they're going to make a pennant, which is in the shape of an isosceles triangle, so two sides are the same length. Now, they're going to have the overall perimeter at 149, so we're going to have two sides that are the same length, and then this side here, which is a fixed size. Now, we don't know what the base of that is, so we're going to call that x. And as we read this, it says, if each side equals twice the length of the third side, so twice the length of this third side here, increased by 12. So this third side, is x, and then these sides, which are the same, are 2x plus 12. 2x plus 12. And now we've set it up using a diagram to help us, translating the information we have here onto the diagram, and there's our equation. So we get 4x plus 24 plus our base is 149. So we get 5x, and we're going to subtract by transposing 24 from both sides here, the other side, a negative 24. And using my calculator, I get 125. Divide both sides by 5. I get x is 25. So I put 25 in my original diagram. 2 times 25 is 50, plus 12 is 62. And these then are the dimensions of my pennant that adds up to 149. And it checks out nicely. And I would go along with what they've shown here, similar to what I've done. Now we're going back to what we had originally, finding consecutive integers. Here, this person, let's read it carefully. Her last 3 tests were 3 consecutive even integers whose sum was this. So again, if they were even, it would be like 8, 10, 12. So we're going to say the first integer is x. The next even integer was x plus 2. And the next even integer, x plus 4. So they have it set up nicely here. There's our first integer, our second integer, our third even integer adds up to this. So then we get 3x plus 6 equals 264. We're going to transpose that or subtract it. We get 258. We're going to divide both sides by 3. So our 3 consecutive even test scores, 86 for the first, 88, and 90. And if you add these up, it adds up to this. But you need the algebra to show the work. This one's sort of an easy one. You could almost figure this out using guess and check. But we want to see the equation that you write using algebra. And there's the work. All right, going on to vocabulary check now. And our mini lecture problems coming right up.